All right, hey guys. So I'm going to go through this homework with you guys real fast in case you got stuck on any problems. Hopefully this is helpful for your quiz tomorrow. So the first problem, if we take a look at number 1, we have just a system that we're solving using substitution. So in this case, fortunately, we already have one of our equations in the form x equals. Remember, you have to always start by either making x equals or y equals. You don't have to do any work for that in this case. You just can find that x equals, oh, sorry guys. You can find that x equals negative 2y minus 3. So whatever you have here that's x, you're going to find x in the other equation, and you're going to sub in what x is equal to. So that negative 2y minus 3 is going to go in x's place. So you'll get 4 times, instead of x, we're going to put in negative 2y minus 3. We're going to close our parentheses, and then bring the rest down. Plus 5y equals 3. Then we simplify and solve. The 4 gets distributed to both these, and we'll get negative 8y minus 12 plus 5y equals 3. Then you collect your like terms. Negative 8 and positive 5 are alike. If you add those, you'll get a negative 3y. You bring in your minus 12 equals 3. And then it's a two-step equation. You add 12 to both sides. This gives you negative 3y equals 15. And then finally, you solve this by dividing both sides by negative 3. And this will tell me that y equals negative 5. Once you have y, if you want to find x, you can go back and plug into either of your two originals. But it's usually easier to plug into the one that's x equals. So I'm going to use that one, x equals negative 2y minus 3. I'm going to replace my y here with a negative 5, because I know that y is equal to negative 5. And that will give me x equals negative 2 times negative 5 minus 3, which is positive 10 minus 3. So x equals 7. So now that you know x equals 7, y equals 3, you can express this as an ordered pair. It's 7, negative 5. Okay. All right, so that's if it's already set up. If we look at question number 2 here, this is one where it's not quite set up because you don't have an x equals or a y equals. So your first step is to make one of them x equals or y equals. Now, while you could do that for either equation, what you want to look for is the variable that does not have any coefficients, that's by itself. In this case, that variable is the y in the second equation. So what I'm going to do is I'm going to take this second equation, 2x equals y plus 3, and I'm going to get y alone. Sometimes people get confused with this type of problem because y is on the right-hand side, but you don't treat it any differently. To get y alone, you have to get rid of the thing that's with it, which in this case is a plus 3. The way I get rid of a plus 3 is I subtract 3 from both sides. Here it will cancel. Y will be alone on this right-hand side. And on the left, 2x and minus 3, they're not like terms. So you write it as 2x minus 3. I'm sorry about that, guys. So that's 2x minus 3. Okay? Then, you know that y is what you're looking for. You're going to replace y in this other equation with a 2x minus 3. So if you do that, you get 3x minus 4. Instead of y, we're putting in 2x minus 3. And then this is equal to negative 8. We just copied on this equation, just switched out the y. So then you're going to solve this. The way we solve this is we first distribute this negative 4 to both numbers inside the parentheses. This is going to be 3x. Negative 4 times 2x is a minus 8x. And then negative 4 times a negative 3 is a positive 12, equals negative 8. 3x minus 8x yields 5x, or rather negative 5x. You bring down your plus 12, equals negative 8. And then you just subtract 12 from both sides. This will give you negative 5x equals negative 20. And then finally you solve by dividing both sides by negative 5 to get that x equals 4. Okay? Once you have x, you can find y by plugging back into either the originals, or better yet, you can plug into this one that's already got y alone, this one here. Okay, so let's do that. This one I can write in the other order. All right, sorry, I have dogs in my house making a bit of noise. But you can replace your x with a 4. This will give you y equals 2 times 4 minus 3. That's y equals 8 minus 3. So y equals 5. So my solution is 4, 5. Okay? All right, so those are the most common types, those two substitution problems like these. The next type is question number 3, and that is where you're solving a system by graphing. Now, we've solved the system by graphing last week, but if you remember, on Friday and on Monday, we did somewhere like this where y was not alone in one of the equations. So let's work on that one. The first equation, you don't have to do anything special with it. It's already y equals in slope-intercept form. So I can just pull out my slope, m, and my y-intercept, b. So my slope, m, is the number with the x. In this case, that's a positive 1/3. My y-intercept, b, is the number by itself. In this case, that's a negative 2. So I'm going to start here at negative 2. And then my slope, because it's positive 1/3, that tells me to go up 1 and right 3. Up 1, right 3. Up 1, right 3. And I will connect these with as straight of a line as I can draw. Okay, something like this. All right, the next one. It is not currently in the right format. I need to get it in the form y equals. So that means I'm trying to get this y here alone. That's not too hard to do. You got to get rid of this plus 7 that's with it. The way you do that is I subtract 7. Here it will cancel. I'll have a y on the right equals, and on the left, 2x minus 7. It's okay for it to be on the left and on the right. It doesn't have to be in any particular order. So then you can go ahead and graph this because y is alone. Okay. So for this one, my slope is the number with the x. In this case, that's a positive 2. My b is the number by itself. In this case, a negative 7. So I'm going to start down here at negative 7. And my slope tells me it's 2 over 1. So it's going to be to go up 2 and over 1. So I go up 2, right 1, up 2, right 1. And I connect these with a straight line graph. And of course, my solution shows up where these two lines intersect, which right here, the x value is 3, and the y value is negative 1. So the solution to this one is 3, negative 1. Okay? Last one on this worksheet. You were asked to solve this system, or solve this word problem with a system. This is what we did today. At high school, 40 tickets were sold. Student tickets cost $2. Adult tickets cost $5. The total revenue was $110. How many student tickets were sold? How many adult tickets were sold? The first step is to establish what x and y mean. And that's always going to be whatever is being asked for. In this case, it's pretty clear. It's asking for how many student tickets and how many adult tickets. So let's make x the number of student tickets. And y be the number of adult tickets. Okay? Then the equations. One equation is a count equation. We know there's 40 total tickets sold. So because some are students and some are adult tickets, the way I can find this, I can just add those two together. X is student tickets, Y is adult tickets, and if you add those together, you should get the total tickets, which we know is 40. The next equation is kind of the money equation. Students tickets cost $2. If X is student tickets, then 2 times X is how much money you got from student tickets, because each one's 2. You multiply the number by the number you sold. The adult tickets are 5, so for similar reasons, it's 5 times Y. And if you add those two together, you should get the total revenue, which we know is $110. Okay? Once you have this system, you're ready to solve. So we're going to solve the first equation here for one of your variables. I have x plus y equals 40. Okay, I'm going to solve for x here. It really doesn't matter because neither one of these variables have a coefficient, but I'm going to solve for x, which means I'm going to get rid of y by subtracting y from both sides. This will give me x equals 40 minus y. Now that x is alone, I can find my x and in the other equation and replace it with 40 minus y. Okay. If I do that, I get the equation 2 times 40 minus y plus 5y equals 110. Then I'll simplify and solve like I did numbers the first two on this worksheet. So I distribute the 2. 2 times 40 is 80. 2 times a negative y is a minus 2y. You bring down your plus 5y equals 110. Then you collect your like terms. Your like terms here are negative 2y and positive 5y. If you add those together, you get a positive 3y. You bring down your positive 80, and your equals 110. And then you solve by subtracting 80 from both sides. This will give you that. These will cancel. You'll have 3y equals 30. And then finally, you divide both sides by 3 to get that y equals 10. To find x, you plug this back into this other equation. X equals 40 minus 10, because y is 10, which means that x equals 30. Make sure at the end here that you do express your answer with units. X is student tickets, so that means we have 30 student tickets. And y is adult tickets, so that means we have 10 adult tickets. Okay. So that's going to be the end of this. Hopefully you remember how to do all this. You feel comfortable with it, but if not, you're welcome to come in tomorrow morning and get some extra help. All right. Thank you. Have a good night.